Oh, that looks great. This is the result of today's project, which is all about taking damaged laptops and converting them into beautiful desktop media PCs. It's great for the environment, great for your pocket, and great fun. Let's get to it. From all angles, this combination of wood and aluminium looks really striking, and it's very unique for a computer. Some of its design elements are actually a result of its internal workings. For example, the finned aluminium on the side is actually a heatsink for the processor, and the brushed aluminium below it houses a fan that gently circulates the air, keeping it cool. As this fan has been soft mounted and spins slowly, the PC is silent, which makes it a pleasure to use, whether you're watching YouTube videos or browsing the web. I have mine plugged into the lounge TV, and in combination with a wireless keyboard that has a built-in trackpad, it is comfortable to use from the sofa and results in an experience as good as any expensive smart TV for a fraction of the cost. So before we get going with the build, I'm happy to say that this video has been sponsored by Dashlane, which is a free and premium service for managing all of your online passwords. Now, if you have heard the official advice, you'll know that we're supposed to use unique passwords for all of the online accounts and services that we use, but we all know how difficult that is to keep, and that's where Dashlane comes into its own, because it can store, manage, and even generate all of these different passwords for you, so you don't have to keep on remembering and entering them yourself. Now, it's super secure because it's all encrypted, and it works across all major platforms like Mac, Windows, iOS, and Android. And if your device has a fingerprint sensor, it can utilize that as well, which is my personal favorite feature as it makes it super fast to use. So sign up for free using the link in the description, which will add all of the premium features to your account for 1 month. Now, you can keep using the free version for as long as you like, but if you did enjoy the premium features, you can find a 10% discount code for it in the description. Now, I've actually installed it on the Media PC, which will be super handy, so I don't have to enter any passwords. Speaking of which, we can begin building now. As I mentioned earlier, this project is perfect for giving new life to laptops that function fine internally, but have some kind of external defect, like a smashed screen or perhaps a non-working keyboard. My laptop cost just £12, which is about $15, and is powerful enough for everyday use as it has an Intel i3 processor and plenty of RAM. The first thing to do is begin disassembly so that we can remove the internal components from the plastic casing. Generally, laptops are held together by lots of screws on the bottom, which all need to be undone. The exact process for this will vary from laptop to laptop, so I won't go into too much detail here, but generally you can just muddle through it to get it all undone, as it doesn't need to be put back together afterwards. Sometimes the screws aren't that obvious, and may even be underneath stickers and around the back. My laptop required the panel above the keyboard to be removed, followed by the keyboard itself, before I could access the remaining screws that were holding the chassis together. Now that we're in, we can see the motherboard, which can be carefully lifted out, and at this point it's important to give it a test to make sure that it still works properly. The power button for mine is on a separate little board, so after removing this and clipping it back into the motherboard, a monitor can be plugged in, as well as the data drive and a power adapter. Will it work? Yep, the hard drive and fan spin up and it soon boots into Windows. One thing I did notice though is that the stupid little fan on it is annoyingly loud and whiny. As we're supposed to be building a media PC, having such a racket isn't an option, so we need to do something about it. Thankfully, the cooling unit is easy to remove by undoing a few screws. It could come in handy for a future project of some kind, so I'm going to save mine for such a time just in case. The processor still needs to be cooled, however, so I'm going to add a much bigger heatsink from an old desktop PC. I found this one in my parts bin, and it's absolutely huge compared to the original cooler. Now, it does have a fan on it, but ideally I'd like the Media PC to be silent, so I'm going to try removing it to see whether the cooler is capable of keeping the processor in check passively, as the heatsink is so much bigger than the one it's replacing. After adding a little bit more thermal grease to the processor to aid heat transfer, I balanced the heatsink on top and then booted up the system, except for it didn't. The lights were on and the hard drive was spinning, but nothing was appearing on screen, almost as if it was dead. I'd been pretty careful though, so I wasn't panicking too much, and it actually turned out to be simply because the fan wasn't plugged in, which halted the boot up process. This is putting my plans of passive cooling in jeopardy, but we'll carry on and sort it out later. So to test it out, I launched a program called Prime 95, which puts the processor under an intense artificial load to stress it as far as it will go. Temperatures steadily climbed over about 20 minutes and eventually hit a ceiling at around 80 degrees Celsius. Occasionally it would bump up to 85 degrees, which would trigger thermal throttling, which dropped the temperature back down again. So while the system was completely stable, and thanks to the thermal throttling would never properly overheat, these temperatures are higher than ideal, so it may not be worth going the passive route after all. For now anyway, the heatsink can have a few holes drilled into it so that it can be mounted securely to the motherboard from the back using 4 screws. Now, as the chipset next to it also gets quite warm, I used some thermally conductive glue to attach a small heatsink to it to keep it nice and cool. So with that done, it's time to get going with the rest of the build, and the first thing we can tackle is the mounting platform for the motherboard. For this we'll need some aluminium sheeting that's about 1.5mm thick, onto which the perimeter of the motherboard can be marked with a knife. These grooves can then be deepened so that the aluminium can be bent along them repeatedly until it breaks free. Optionally, you may want to follow any gaps around the outside of the motherboard, as these can be handy for making space for internal wood supports or components, as you'll see later. We can now make various holes in this sheet corresponding to a few of the motherboard mounting holes. Any extra components need to be catered for here as well, like the data drives. I got the correct positioning for these by breaking through a piece of paper and then marking their locations on the aluminium using a sharp point. Any burrs that are left behind by all this drilling, by the way, can be taken care of by twisting a large drill bit over the holes by hand like so. Once all of the holes have been created, any protective film needs to be peeled off and the whole thing given a wash with water to remove any aluminium particles, as it wouldn't be very good for these to come into contact with the electronics. So the first components to mount are the data drives. The original laptop used a hard disk drive, but this was a major bottleneck for its performance, so I'm going to replace it with a solid state drive, which has no moving parts, so helps the computer run significantly more smoothly. It can't hold as much data as a typical hard drive can though, so for additional storage I'm going to mount a secondary hard drive that has a huge capacity in comparison. So with these secured in place, it's time to add some PCB standoff pillars for later mounting the motherboard. Mine are 15mm high, so are just long enough to hold the motherboard above the hard drives without touching. Before screwing the board in place though, we need to plug in all of the cables that attach to its underside, as we won't be able to access this area later. Here I've attached the power button wire and Bluetooth module. Another consideration is the audio sockets. As I'm planning on passing the audio through to a television using an HDMI cable, it doesn't matter too much, but I'd still like to have the option of using the analog audio output should I need it. Unfortunately, the side of the motherboard that they're on will later be the top of the case, and I don't want any visible ports there, so I need to route them elsewhere. I did this by soldering a headphone socket to a length of shielded audio cable, and then soldered the other end to the appropriate pads underneath the audio output port, which I discovered by using a multimeter on beeper mode. One of the pads needs to be connected to ground, as it is a sense connection that tells the computer whether something is plugged in or not. With it connected to ground permanently, the PC will always assume that something is there to send the audio signal to. Right, so now some SATA extension cables can be plugged into the data drives and the motherboard screwed in place. The SATA cable for the main solid-state drive happily plugs into the original port, but the one for the secondary storage doesn't fit at all. What's going on here? Well, the secondary port on the motherboard is a SATA port, but it's designed for use with an optical drive rather than a hard drive, and uses what's called SATA Slimline. The data connection for this is identical to a full-sized port, but the power side is slightly trimmed down to take up less space. You can buy little cables to convert it to full size or wire one up yourself, but I had a little optical bay to hard drive adapter, so I pried it apart to get the connector out, which allowed it to be hooked up without any fuss. So with that, the motherboard and components are successfully grouped together into a nice solid platform, and we can begin working on what will become the visible part of the case. For this we can cut 2 matching panels out of some kind of wood. I'm using MDF as it's cheap and easy to work with. To make the curve on the top front corner, I used a compass to mark it out and then cut along it with a coping saw, smoothing it off with a sanding stick. The components need to be mounted onto one of these panels, so the mounting hole positions can be marked with a pencil. I added these mounting holes to the aluminium sheet earlier, and there are 3 of them, which is all it takes to hold it securely in place. I used some short screws for this so that they wouldn't go through to the other side, and added some washers to hold it slightly off the surface, allowing room for the heads of the other screws. With the other panel, I cut out a rectangle so it could fit over the heatsink, and to help this stand proud against the back panel, I added a couple of wooden battens, holding them in place with glue and countersunk screws. This being MDF, it is a very boring material to look at, and it definitely needs to be spruced up. So to do this, I'm going to use some veneer, which is real hardwood sliced into extremely thin pieces. As some veneer shrinks when it's first applied, give it an iron first just to pre-shrink it. Now the panel and veneer sheets can have at least 2 coats of wood glue applied to them. You may need to add a tiny amount of water so that it spreads more easily, and once it's thoroughly dried, the pieces can be trimmed down to size and a hot iron used to press it firmly in place, which slightly melts the glue and sticks the 2 pieces very strongly together. Make sure that your iron doesn't have any water in it, by the way, as we don't want steam puffing all over the place. Once all of the bits have been added, they can be trimmed down along the edges and then sanded smooth with fine grit sandpaper. As you can see, this is starting to look really nice, and I did a similar job for the back panel as well, this time going with a more natural edge that follows the grain of the wood rather than a straight line. The next thing to do is cut out a piece of wood to act as the base. This piece is actually going to be one of the 2 anchor points that holds the front panel in place, so I've screwed on a piece of angled aluminium to act like a big bracket, after which the wood piece can be glued to the front panel. The aluminium angle, by the way, needs to have 2 threaded holes made in it to allow screws to lock into place for mounting purposes later. So every good computer needs a power button. To add one here, we can simply drill a hole for it and lock it in place with a nut. This of course needs to be hooked up to the power switch on the laptop, so I used my multimeter to find out where to attach it to. Turns out that it's simply 2 of the lanes on this ribbon cable, so I removed it and soldered the power button wires directly to it. Another thing I needed to do was replace the power input jack, as the original wasn't long enough to reach where I wanted to mount it. I actually mounted this new one onto a small block, along with the replacement analog audio socket, which then got glued to the platform in between the gap I made in the aluminium right at the start. See, I told you it had come in useful. So now there's one last thing to sort out before the case can be closed up, and that's what to do about the cooling. As you saw earlier, passive cooling temperatures were really a bit too high to be considered comfortable, so some kind of fan does still need to be added. Now, the fan that was on the heatsink at the start was large and ugly, so instead I decided to mount a small one that could blow cool air up towards and through the heatsink blades from below. So the first thing to do is chop off the connector and solder the sense wire to the original fan socket, which should take care of the requirement for the motherboard to sense that a fan is present before allowing the system to boot. The remaining 2 wires, which are power wires, can now be hooked up to a 5-volt power source on the motherboard. I had a look at the pin configuration of a SATA connection online and soldered the wires to some conveniently placed pads on the SATA Slimline adapter I salvaged earlier, which will deliver 5 volts to the fan whenever the system is powered up. This voltage, by the way, is far lower than the 12 volts that the fan was designed for, which is intentional as it means that the fan spins much more slowly, making it literally silent unless your ear is about 10 centimeters away from it. At these speeds though, vibration noise becomes the most apparent sound, meaning that if the fan touches something solid like the panel, you can hear a slight hum. So to isolate it from the surface, I made some little aluminium L brackets and stuck some sponge to them, which in turn were glued to the fan. This does a fantastic job at isolating the hum and is much quieter than direct hard contact. Once the L brackets were glued in place, I made a little plastic shroud to direct the airflow through the heatsink's fins. So after salvaging the Wi-Fi antennas from the screen and gluing them to the inside, the front panel can be screwed in place. The bottom screws thread into the aluminium angle that was added earlier, and the top ones thread into the wooden baton. So the build is almost complete now, but there are a couple of things left to finish off. The first of these is to bend a piece of aluminium to fit over the front and top, gluing it in place to the front panel using some epoxy. As it's only stuck to the front panel, it allows the front panel to be removable, which is important for any PC for maintenance purposes. Now to make a cover for the fan and its shroud, we can get another piece of aluminium and score some strong grooves in it and tightly bend it at 90 degrees. As this makes an ugly corner, we can now take a file and flatten it out like so. To remove any scratches, we can now take a piece of very fine grit sandpaper and run it along in one direction, which gives it a lovely brushed appearance. Now it can simply be glued in place. The back of the case, where all of the ports are, is left open to allow air to be taken in at the bottom and vented out through the heatsink. Sometime I plan on adding a fine mesh to this though, to improve it visually. The very last thing to do is add several coats of finishing oil to some of the veneer. I've chosen to add it only to the darker wood, as I'd like to have a contrast between the soft natural oak and the deep rich gloss of the darker wood. And with that, the protective film can be peeled away. Oh, that looks great. So that's it for this video. I'm personally really happy with how this one's turned out, because it looks like a piece of art as well as a functioning PC, and it's a great use of an old laptop. Now, if you make one of these yourself, don't forget that you don't have to use veneer. You could use something like leather or vinyl wrap, or even you could print something on glossy paper and use that instead. You know, go wild. It can be a really good creative outlet, and you'll have something unique at the end of it. Now, if you do make one of these, don't forget to send me a picture to my Twitter account at DIYPerks. But other than that, if you're new to the channel, don't forget to subscribe, and I hope I'll see you next time. Goodbye for now.